So suppose we have two lines and we want to find a way to tell if these lines are perpendicular. Well, I know these two lines are perpendicular because I drew them that way. And I drew the first line, I drew one of the lines. Then I made a copy of it and told the program to rotate it 90 degrees and then lined it up here with the other one. So I know that these two do meet the geometry definition. Let's see what we can do for coming up with an algebra definition. So what I want to do first here is see if we can figure out what the slopes of these lines are. Because fundamentally, when we're talking about perpendicular, we're talking about comparing the directions that the two lines are going in. And in algebra, we numerically identify the direction the line is going by its slope. So let's see, I'm going to start with this upward angling one, this one here. Right, so I see that it's going through this point and this point. All right, so the lower one here, this is 0, -3. This one over here is 4, 0. So let's call this line 1. And the slope of that line is, let's see, the difference of the y coordinates, that's -3 minus 0 over 0 minus 4. That's -3 over -4, which is positive 3/4. Okay, well, good. Now, let's take a look at the other line and see what's going on there. So I want to do kind of the same thing here, right? I'm going to start, I'm looking for, they're called lattice points, right? Points that look like they're going through a pair of grid lines. So the point down here is 0, 0, and the point over here, this is -3. Let me move that over a little further. -3, 4. And again, let's give this a name. We'll call this line 2. So slope 2 is 0 minus 4 over 0 minus 3. So that will be -4/3. All right, now compare these two. Right, compare these two numbers. You see they both have the same numeric parts. They both have a 3 and they both have a 4. Right? But their position is reversed. One has it on the top, one has a 3 on the top, the other has a 3 on the bottom, for example. You also notice that their sign is reversed, and we really kind of expected the sign to be reversed. Because if two lines are perpendicular, then they have to be going in different directions. If one of them is angling up, the other has to be angling down. So it makes sense that the slopes will be different. And this pattern here of changing the sign and flipping the number over, that's where our definition of perpendicular is going to come. So I have two definitions here that are based on what we saw in the previous slide. And they both say the same thing. Right? They just do it a little differently. So my first definition says, two lines are perpendicular if and only if their slopes are negative reciprocals. Okay, so what does that mean? Well, let's look at an example, right? Let's say the slope of one line is 4/5. Right? What is the slope of the line perpendicular to it? Well, the definition says it's the negative reciprocal of 4/5. Right? The negative part means the sign is reversed. So instead of being positive, this one is going to be negative. And the reciprocal part says that we need to flip the fraction over. So the slope of my perpendicular line will be -5/4. So let's try this with another example here. Let's say the slope of my original line is -2. Right, what is the slope of the line perpendicular to it? Well, it may not be immediately obvious what the reciprocal is going to be. But remember, -2 is the same as -2/1. Right, so the negative part says the sign changes, so instead of being negative, it's going to be positive. And the reciprocal part says the number flips over. So instead of 2/1, it's 1/2. And there's my reciprocal, the slope of my perpendicular line. Okay, the second part, and we'll see how this means the same thing. Two lines are perpendicular if and only if the product of their slopes is -1. Well, you can see that happen here. If we multiply these two slopes together, for example, 4/5 times -5/4 is -1. And if we do it over here, we get the same thing. -2 times 1/2 is also -1.